Hello, my name is Nick Ruprecht, and today I'm going to be talking about how we can anthropogenically enhance the weathering of silicate rock to help slow the rate of climate change. I am doing this as my final presentation for Geology 4533, or Earth's Past Climate. So as an overview, today in this Petra Kucha, I'm going to be covering the main problem that I'm focusing on, classifications of a silicate rock, two main silicate rock focuses of olivine and basalt, and a little bit about each one, their weathering properties, their weathering techniques, olivine CO2 reduction, and also the cost behind each one. The main problem I'm going to address today is climate change, specifically how we can help absorb major amounts of emitted CO2 in our atmosphere. We've gone from around 280 parts per million of CO2 pre-industrial revolutionary times to over 400 parts per million today. This rapid increase in CO2 levels have led to an increase of many natural disasters like wildfires, tropical storms, droughts, food shortages, etc. So, what classifies a rock as a silicate rock? A silicate rock is a rock-forming mineral made up of elemental silicate groups. It makes up almost 90% of all of Earth's crust, so there is an abundance of anthropogenic sources here for silicate rocks. So ultimately, what does the weathering of silicate rocks do? Well, when weathered, silicate rocks react with the water and air, and they actually absorb and permanently store and sequester carbon dioxide from the atmosphere in solid carbonate minerals or the ocean. Now, how can we anthropogenically enhance this type of weathering? We can enhance it by spreading and supplementing silicate minerals into regions of high weathering activity, such as high rainfall, to speed up the process described in the previous slide and accelerate the rate of carbon dioxide absorption from silicate rocks. Today, I have two main focuses. First is olivine. Olivine is a magnesium iron silicate. This kind of rock is the primary component of the Earth's upper mantle and has a vital contribution to the natural weathering CO2 absorption amount that occurs every single year. So, what are some of the weathering properties of olivine? Well, olivine is a rapid weathering mineral, which means it has a very reactive surface area. However, the hesitancy towards enhancing weathering of olivine is that it has the potential to release harmful substances like nickel and chromium. So now for weathering techniques. When it comes to weathering techniques for olivine, scientists have focused on land-to-ocean weathering techniques because that is where olivine is weathered most predominantly. The majority of the time, olivine is broken down into sand-sized minerals to increase its capabilities and functions. Now, if we were to mass reduce and distribute olivine throughout our agricultural fields and shallow waters, we could enhance CO2 removal by 95 billion tons, almost 90 times greater than the natural weathering reduction of CO2 that takes place. And, as of 2021, the global CO2 emissions are around 40 billion tons, so we could theoretically double the amount of CO2 absorption that we are emitting. Another plus side for ocean-to-land weathering of olivine is that it can lead to soil enhancement and enrichment, mineral sequestration or a reaction to create carbonates, high levels of CO2 absorption, and ocean alkalinity enhancement to help trap CO2 in the ocean rather than in our atmosphere. According to a study conducted by Project Vesta, which is an organization who is focusing on implementing olivine onto beaches to help sequester carbon, they say that the price per ton of stored carbon on the large scale is approximately $10. However, olivine has the potential to store hundreds of trillions of tons of stored CO2, so to maximize the power of olivine, it would cost the world approximately a quadrillion US dollars. So that's for olivine. My next focus is basalt. So basalt is an igneous rock formed by the cooling of low viscosity lava rich in magnesium and iron. It makes up almost 90% of all volcanic rock on Earth, so it is another major deposit of silicate rock that humans have access to. Now for its weathering properties. Crushed basalt is a very rapid weathering mineral. It has a very high reactive surface area per volume. So this means that when implemented into regions of high precipitation, basalt is a theoretical machine when it comes to sequestering carbon dioxide. Now for its techniques. Many agriculture powerhouses of the world like China, Brazil, and other various African and South American countries have started to make the shift away from pesticides and to crushed basalt. This is due to the fact that basalt not only traps CO2, but it also has been linked to increased crop fertility and overall crop production. If we were to mass reduce and distribute basalt throughout our agricultural fields and shallow waters, we could enhance CO2 removal by 4.9 billion tons, almost 5 times greater than the natural weathering reduction of CO2 that takes place. And, as stated previously as of 2021, the global CO2 emissions are around 40 billion tons, so we could theoretically remove a tenth of CO2 emissions that are occurring every year. Like stated previously, basalt has both high carbon dioxide absorption capabilities, but expanding on crop yields, many countries are making the switch to crushed basalt on their agricultural lands to increase their levels of crop productivity and overall well-being of the climate and future soil enrichment with respect to crop yields. According to Journal Nature, treating half of the global farmland could capture 2 billion tons of CO2 each year. The average labor cost for sequestering this carbon is around $125 per ton of stored CO2. Looking at the cost breakdown, it would cost the world a minimum of $1.75 trillion and a maximum of $3.25 trillion each year. In conclusion, even though basalt may not be as effective in absorbing CO2 as olivine or dunite, personally I believe it is the best option, considering it can help increase crop yields, doesn't emit harmful chemicals, is substantially cheaper, and still absorbs 5 times the global natural weathering amount of CO2. In summary, I went over the main problem of climate change and how we can use the enhancement of weathering of silicate rocks to increase CO2 absorption and therefore slower the rate of global warming and climate change that is plaguing our planet. I do not consider this slide one of my 20 slides as it is just my references, but I did want to say that I obtained 3 peer-reviewed sources and 3 regular websites, all of which focused on the main 2 silicate rocks discussed. Thank you so much for listening to my Pecha Kucha today. I had a great semester and I hope to see everybody again. Thank you.